The universe is huge. It's truly enormous. If at its current speed of over 38,000 miles per hour, Voyager 1, the farthest man-made object from Earth, would take more than 73 millennia to reach the nearest star to our Sun, Proxima Centauri. If we ever want to explore beyond our solar system, then we need to alter the laws of physics to make faster-than-light travel possible. Scientists are looking for methods to improve technology so that they can develop faster and more efficient spaceships as interest in space travel grows. While studying the formation of Casimir cavities, a group of scientists made the unintentional discovery of a real-world warp bubble, a modest step toward developing a potential warp drive. But what is a warp bubble? Is it possible to travel faster than light? And how can this develop space travel? Keep on watching to find out more. So, what is a warp bubble exactly? A warp bubble is a piece of space that is contracted in the front and expanded in the back. It's a difficult concept that requires a lot of math, but at its most simple level, it's a bit of space that is contracted in the front and expanded in the back. The contraction hypothetically drives the bubble and its contents ahead at speeds higher than the speed of light without breaking the laws of physics. You're not really traveling faster than light, you're riding a condensed space bubble. Warp bubbles are also important because they eliminate a major problem of faster than light travel, time dilation. Say you did manage to travel faster than light, everything else outside of your craft would speed up, meaning that 3-hour tour you took to a nice, warm planet could have cost you years of time passing on Earth. Put simply, if you plan to move faster than light while following the known laws of physics, you had better say goodbye to everything you've ever loved before heading out. Again, warp bubbles solve this problem because the environment inside the bubble is unaffected, so an hour of warp travel will only take an hour for anyone else who isn't currently in a pocket of sci-fi space. Warp bubbles have always been the stuff of sci-fi, until Miguel Alcubierre, a theoretical physicist, presented his Alcubierre warp drive in 1994, that kept general relativity while permitting faster-than-light travel. The key to unlocking it was an energy density field that could be configured into a vacuum bubble, providing anything within its negative mass. The method was commended for its clever mathematics, but it was criticized for relying on theoretical material and massive amounts of power that appeared to be practically impossible to produce in any practical sense. White, a NASA-employed warp drive specialist and the inventor of the highly praised Eagle Works laboratory, modified Miguel Alcubierre's original metric and put it into canonical form over a decade later, and this hypothesis underwent a fundamental shift. This adjustment in design drastically decreased the exotic materials and energy requirements of its original plan, giving scientists and science fiction fans alike optimism that a real-world warp drive might one day become a reality. It also resulted in an informal rebranding of the original theoretical design, which is now known as the Alcubierre/White warp drive. Since then, the debrief has featured several physicists and engineers who are attempting to create a feasible warp drive on their own, including an entire group of worldwide researchers who are working on a warp drive that does not require exotic matter. The only problem is that no one knows how to stop traveling faster than the speed of light, and return to flat spacetime upon reaching your destination. Some also argue that some normal propellant within the bubble might still be needed. Eric Lentz explains how warp drives could be made possible by a soliton that flows through spacetime as a wave function. In Lentz's concept, instead of Alcubierre's idea, where spacetime expansion occurs behind the ship and contraction occurs in the direction of movement, both expansion and contraction happen on all sides of the soliton. The soliton is spacetime itself, which has a bent shape but is still stable. At the same time, there are also many researchers who have their doubts. And those doubts don't just concern the feasibility of warp speed. Some researchers are also very concerned about its safety. For example, people in a spacecraft traveling almost as fast as light would be bombarded by dangerous radiation and almost certainly die. Other researchers are not so much concerned about the crew, but about the destination. That destination would be destroyed in one fell swoop when humans arrived in the Alcubierre warp bubble. A spacecraft in warp speed picks up particles along the way and collects them in front of the bubble. When the spacecraft slows down to stop at its destination, the particles collected at the front of the spacecraft are released. These particles have so much energy on board that they instantly destroy everything they encounter. There is therefore a very good chance that a spacecraft that arrives at a destination at warp speed will immediately destroy this destination. It is also not inconceivable that some particles will enter the bubble around the spacecraft. That would mean that the people on board a spacecraft with warp speed are also at risk. Even on short trips. There is no limit to the energy released when arriving at the final destination, said researcher Brendan McMonagle. You can just keep traveling, longer and longer distances, and the energy released will continue to increase. Even for short journeys, the energy released is so enormous that you destroy everything in front of you. In Eric Lentz's theory and bubble, the quantity of energy necessary is somewhere around 1/10 of the Sun's mass. However, he feels that progress in physics may be done in this area, as the quantity of negative energy required in Miguel Alcubierre's theory has already been decreased as the area of research has developed. But what would it mean for a traveler if they were able to generate enough energy for a warp drive? There would be no time paradoxes, as according to Eric Lentz. The very same amount of time would have passed by individuals on Earth as for those inside the warp drive spacecraft if a person traveled from Earth to Proxima Centauri over a 2-year time frame. This is because the spacecraft's passengers would not suffer any actual acceleration. But before we jump ahead to romantic visions of space travel, Dr. White said, we need to think about what we could do with a microscale warp bubble, like the one his team discovered, before even dreaming of what it could be in the future. Dr. White is passionate about space travel, but says we need to start simple. There may be lots of other things along the way before we ever get to the point that could have some really interesting implications, he said. A lot of people want to get straight into application. When are we going to go make something like this fly? I get the motivation for that, but science is a slow, arduous process. Dr. White says his motto has been crawl, walk, run. When it comes to cutting-edge technology, this is the place to be. He believes that dreaming is vital, but so is completing the proper research that leads to finding more applications that are practical and useful. I don't have a crystal ball more than anyone else does. I don't know when this idea could be applied to space travel, or even if that could even become a reality, Dr. White said. That's understandable given we are currently talking about warp bubbles generated in cavities smaller than the width of a human hair. So, there are still some hurdles to overcome before we understand the warp drive and can safely apply it. But, it can go relatively quickly. And if things go fast, we only have one man to thank for it, Albert Einstein. According to astrophysicist Geraint Lewis, his general theory of relativity offers the tools to make warp drive possible. Lewis points out that we are only now beginning to understand Einstein's theory, although it is 100 years old. We gradually get a better picture of what the theory predicts. One of the things coming out of the calculations is a possible mechanism that would allow us to travel through space faster than light. Science will continue to turn the crank and hammer the rock, chipping slowly away at some of the unknown to get to more of the known. Consider this discovery just one chip in the right direction. Only time can tell what the serendipitous discovery represents for the future, but meanwhile, we know it's a giant step forward in the right path. What are your thoughts on the discovery? And do you think we will ever achieve space travel with warp bubbles? Let us know in the comments.